For some reason, my voice is kind of going, so it's a little bit more nasally than normal. So the proportionality of tables and equations. Please stop. See? Teacher Twins 2014, to give credit where credit is due. Warm up. Now, we're not going to spend a whole lot of time warming up on this because we did this yesterday, and yesterday wasn't as challenging as Tuesday, and we're going to be dealing with Tuesday type of situations. Please stop making noise with your writing utensils. Okay, salud. See? Yes. Yes. So, choosing the 4 solutions from each equation and graph them, choose your own values for x. Now, we're just going to move along to the graph, okay, because we have shortened class period today, so we have to move along. I want you to notice something about this. I gave you a little tip yesterday about where it crosses the y-axis. Who remembers that? Where the line crosses the y-axis. Take it. One of you two. No, you were gone. Take a guess. You kind of moved a little bit there. Do you have an idea? Let's see. Do you remember? You do remember saying something about that, though? Okay, good. Whenever we have this guy here, yes, good. Whenever we have that, like a +1, or we have a -1, what that's telling us is where it crosses the y-axis, the same way that we checked our homework just a minute ago. Look, it crosses at 1. That's where the red one does. Okay? The yellow one crosses at -1. See how that's happening? Okay. Also, what do you notice that's different about the blue line in the graph? Abby? It goes through the 0. True. Yeah. It's the only one going down, exactly. And the reason he says down is because in English we read left to right, so we look at it being down. So if we had a slope here, ooh, okay. Let's try that again. If we had a slope here, and we were going sledding on a dangerous toboggan, yeah. Okay, we're going sledding on a toboggan down this way. Toboggans are dangerous, so there's a negative there. So that's a negative. Okay, the blue is negative, so it's going down. That's another thing that you're going to be using next year. So hopefully next year when you're doing more slope-intercept form, you'll remember that. And you'll be like, hey, I remember that one math teacher that we had last year. It was pretty cool-ish. All right. Okay. Yeah. There's only so teachers are going to be so cool. I mean, it's not like sometimes, and that's even rare. So yeah, we're not cool. You can try. I know I do. Review. What is a ratio? Can someone please give me an example of a ratio without using nouns? Yeah.
6 to 5.
6 to 5. Beautiful. Okay. Can someone give me a ratio with using nouns? Yeah.
A ratio can be 6 to 2.
True. That's a sentence, but I need nouns. People, places, or things. Yeah. Okay, the ratio, so you're doing odds. Cool. So success and fail, yeah. Beautiful. 6 boys to 5 girls. That's probably the most applicable to this. Okay? Applicable to this is 6 boys to 5 girls. Good. So how about a proportion? Now let's talk about this 6 boys to 5 girls. Would that be a proportion possibly? Okay. Would you say that if the class next to us also has 6 boys for every 5 girls, that would be proportionate? Our class ratios are proportionate? Yes? Good. Let's look at example number 1. Now we're at the notes. Let's look at example number 1. A table is proportional if the ratios of y and x are all equal. And the way that we are going to find this is by doing this. Draw this right next where it says example 1 colon. So you're going to say, 2. I want that red. There. To find ratio. Wow. You'll use y over x. So we're going to find out these guys are proportional to each other. So in order to do y over x, what I want you to do is, I'm going to do the first one. So we have y is negative 4 over negative 2. And we want it to stay as a fraction. So what can I simplify that as long as it stays as a fraction? Yeah. It's actually just going to be 2 over 1. All right, I want you to do that for all of them except for this one here. Do that right now, please. The reason you're not doing the 0 is because you cannot divide by 0. Salud. Okay, you should have that. All of them are going to be 2 over 1. Every single step of that is proportionate to the relationship, okay? They are all going to be proportionate to each other. It equals the same thing. Now, really quick crash course into why we can't divide by 0. Okay, the reason that we cannot divide by 0 is because when we have something, if we wanted to divide one thing into 2 equal parts, we still have something, okay? It's still there. Okay? We split that $1 into 2 equal parts. Do you agree?
Yeah.
Okay? When you're dividing something, you have one thing and you're dividing in what? Oh, it's 25. Darn it. I knew something was wrong. Yeah, it could be. All right, let's try that again, shall we? That was almost going well. So we broke it into 2 equal parts, which is 50 cents. Okay, that's what I was thinking. 2 equal parts, which is 50 cents. Now, because of the law of conservation of mass, you cannot take one thing and divide it into 0 parts. That's impossible. Okay, you cannot take something and make it into nothing. Magic isn't real. Okay? It isn't. What it can be is it can be a situation where you can try to make people think that things are going away, but it really isn't. It's just getting thrown behind their ear. Okay? There. Okay? But it's just illusions. All right? What you can do is you can take one thing and break it into 2 equal parts, but you cannot take one thing and make it into nothing. That's impossible. Okay? All right? You cannot. All right, back to it. The constant of proportionality. I want you to write this definition to the right side. You're going to do it right now, right here. Okay? In your guided notes, you're doing it off to the right. For those of you playing at home, here's your notes page. Okay, you are doing it. You're writing this definition right here. Constant of proportionality is the constant value of the ratio of 2 proportional quantities, y and x. What? You got this. It may sound confusing right now. We'll put it into practice, and you'll be just fine. The constant proportionality is the consistent value A ratio of two proportional quantities, y and x. And then below that, we are going to do one of our magical highlighting things. Yes, sir? What? Yeah. Yeah, wait, what, when? When, though? Yeah, it got posted again? That's cool. That's fun. Yeah, it was on Riverbender, right? Cool. Yeah, it's cool. Yeah, that was, I actually do want to print that up and put it up here as well. I was featured in an article. So for this situation, the constant of proportionality is a ratio of 2 to 1, or just 2. So I want you to write below that example 1 that the COP is 2. So, oops, oh no, what did I just do? There we go, okay. I want you to write that the COP, yeah, you know me, is 2, or 2 over 1, okay? COP, the constant of proportionality. Question, sir? You went like this. Okay. You usually do this when you put your hand in your face? Okay. Yeah. Now here's what you're going to highlight. Just below where you put the definition of the constant of proportionality, I want you to put that equations proportional, you're going to be putting this in here. So it's going to be like, this is still to the right of example 1. You can get down towards example 2 now. But you are going to be highlighting this guy. By highlighting, I mean doing this thing. Okay? No, you are going to put that's what it looks like. So COP, when they're proportionate, looks like that. The constant of proportionality looks like that when they are proportionate. It's y equals kx, which is just like we've been doing. Let's go, Johanna. Okay. Well, still listening. You're playing with your nails. Y equals kx. That's just like what we did for homework last night. Remember, k would have been whatever the coefficient was? Remember? Yeah? Yeah. Okay. And then you're going to put that k equals the COP. Okay, not law enforcement cop, but KOP. KOP. Yeah, you know me. Yep. I'm down with COP. The equation for this table is y equals 2x. The constant of proportionality is 2. So here's your k. Here's your k. Okay. Example 2. To show me that you've been paying attention, I would like you to find out what the proportional ratios are of those x and y values, and tell me if it is proportional or not. Go. So you're doing the same thing you did for example 1.
Do we just skip over the 0?
Yes, because you can't divide by 0. That's a good question.
So we just skip 0.
Yep, skip the 0 one. Well, this one. Look, the second one here, that's not dividing by 0. 0 divided by negative 1, you can do that. So you have nothing. Can you divide it into negative 1 groups? Sure you can. It's still going to be nothing. That's okay. I was just trying to trick you a little bit. Trick you and point stuff out. Yeah, because I use a full Windsor, which means that the tongue back here isn't long enough to fit into the groove.
So like sometimes they'll be mixed up.
Yeah, if I did a half Windsor, which is a knot that's like a square, I'd be able to do it. It's a weird fashion thing. Okay. Okay, so this is what you should have. This is what you should have. If it'll work. Okay, -2 over -2 is 1 to 1. -0 over -1 is just 0. 4 to 1 is 4. And 6 to 2 is 3 to 1. That should be a 1 in the denominator there. Okay? Now tell me this. Are the ratios proportionate? Jace? That's exactly what I said. Isn't it? Are they proportionate, everyone? No, they're not. There's actually 5 different situations there. Okay? The table's not proportional because the ratios are not equal. There is no COP. Nope. Because it's not constant, which is proportionate. Now how about this? What's the table of this equation? We have a 0 in this situation. Remember our 0 trick? Okay, because isn't every formula that we're going to do y equals some number times x plus some number? Okay, that's not hashtag you teenagers. Okay, Jace? The 0, that's a good question. Gentleman just asked me, does that 0 trick only work if the 0 is in the x place? Yes, and here's why. No matter what you do, when you have... Okay. No matter what you do, whenever you multiply any number times 0, so here's my number, and whenever I have x as 0, any number times 0 is 0. Okay? So 0 plus that number, when we have a situation like this, we know that this has to be 2. We know that that has to be 2. Now, when I do this, I'm drawing an underline. Underline x plus 2. What would fit in that x to make all these work? What would fit in all of them? Harrison? Okay, 2. Let's try it. Okay, so we'll substitute that in there. Let's go for the first one. If this is -2, okay, you say that it's 2. We're going to have our x value in there. This is just the first one, plus 2. So we have -4 plus 2 is -2. That one checks out. The next one, y equals 0. We already did that one. No, we didn't. So y equals 0. 2 times -1 plus 2 is is it 0? Good. So let's try another one. One last one that we're going to move along. Okay, we have y is 4. Then this guy is 1. 2 times 1 is 2. Plus 2 is 4. That one checks out. We got it. The table is not proportional, so the equation is not proportional. Proportional equations are written as y equals kx. What do you have highlighted on your notes? Y equals kx. Okay? So the bottom line is this. Whenever there's any junk going on here, whenever there's anything that's being added onto it, then that means that it is not proportionate. Okay? It is not proportionate. Also, what can you tell me about this plus 2? What did we do at the beginning of class today? What can you tell me? Yeah, bigger? Yeah, it's going to cross. It's going to cross at the y-axis at that point, so plus 2. Yep. Okay, see how it all comes together? All right. We already did that. Does it? Well, that's because we always go to the left. We could go to the right. There's 1. All right. Did we do this yet? Okay. Jackie wants to buy some pencils for school. If each pencil costs 15 cents, how much will she pay for 3, 5, and 10 pencils? Now, the logic behind this, the mathematics behind this, you guys should be able to figure this out pretty quickly. So let's do it in the mathematical, the arithmetic of it, okay, not algebra. What are we going to do here? How many is it for 3 pencils? At 15 cents each, Jace? 45 cents. Okay, how much for 5 pencils? JD? 75 cents. Beautiful. Then there's twice that much. Bello, how much for 10 pencils? Okay, 150, or as we would say, $1.50. Now let's look at the algebraic form of it. What is the equation? What is the equation of this? Y equals kx plus something, maybe. What's the equation of this situation? Where x is the amount of pencils. X is the amount of pencils, yeah. X times 0.15 equals price. Let's make price. Now, is price the independent or the dependent variable? Corey, what do you think? Do you think it's independent or dependent? Here's the two variables. The amount of pencils and the amount the pencils cost. Which is the dependent and independent variable? The independent is one that does whatever it wants. The dependent changes depending on what the other guy does. The pencils are independent. The price is dependent because there might be 5 pencils like, hey, okay, and they're just like, hi, I'm 5 pencils. Hi, I'm 6 pencils. And each time that the pencils change, then the price changes.
It is now 2:45 and 5th may be dismissed. Thank you.
Do not leave until you have the homework. Sit down, sit down. I don't want anybody saying that they couldn't get their homework coming in tomorrow. Like, you didn't give me the homework? No. YouTube. If you had the homework, you may leave. Last person out, shut the door behind you so I can finish these notes. You're going to be responsible for the rest of the notes. Yep. So as soon as you guys are out, I'm shutting the door and finishing these notes. So I'm going to pause it. And yeah. Actually, there. It's going to look like that for a moment. So I'll be back in 20 seconds. All right, bye guys. Can you close the door behind you, please? All right, let's get. Whoa, okay. All right, it's being weird. Okay, there we go. So the equation for this problem, we just found out that it's 3 times that 0.15. So that's going to be the equation for it. Y equals 0.15x. Is it proportional if it gives a constant of proportionality? Yes, because it follows the rule of y equals kx. In this situation, k is going to be 0.15. So the constant of proportionality is going to be, if it'll go, there we go, proportionate, the COP is 0.15. Now in this situation, remember I said earlier that whenever there's any other junk, there's ever any junk after x, or it's a situation where the problem could be switched around and there's any junk after x, where anything's being added or subtracted. So in a situation like this, we have junk added, junk added, junk added. junk added. It's just switched around to try to trick you, and junk added. So none of those ones that I highlighted are going to be proportional. The only ones that follow the y equals kx are those ones there. So here's another one that follows y equals kx. Here's another one that follows y equals kx. All those other ones are going to not be proportionate because they won't be able to have that exact same proportion when you find a table of y over x. Let's continue. Boom, boom, same stuff we just did. Blah, blah, blah. All right, now write the equation for each table. Table is proportional. Determine the proportion if the table is proportional and give the constant of proportionality. So once again, what I'm going to be doing is I'm going to be taking y over x. Taking y over x. So in this situation, I have, whoa boy. Okay, let's try this again. Line is blue. Okay, so I have 4 over 1, which is going to be, that's it. Then I have 10 over 3. Okay, right away I can tell you that this is not proportionate because 10 over 3 does not simplify in a fraction as 4 over 1. Okay, now I have 10 over 1 on this guy. I'm going to have 11 over 2. Okay, right away I know this is not proportional because these two ratios that I just did do not go the same. Let's try this one. 30 over 10 is equal to 3 over 1. 21 over 7 is 3 over 1. Yes, all these are going to be 3 over 1. So this one is a yes, it does have a constant proportionality, and that is going to be 3. So I know that this one is going to be y equals 3x. So now I have to find out what the equations are for the first two. So I know that they're not going to be proportionate. I have a 0 trick nowhere. Yes, I do. I have a 0 trick right here. So right away, I know that this one is going to be y equals something x plus 9. So I need to find out what is going to go in this red box here. So I'm going to look at, let's see, we'll look at this guy, which is, if I were to substitute 1 in there for x. What times 1 plus 9 is x? What times 1 plus 9 equals 10? So I put 10 in this situation for the y. So I'm just substituting here. Okay. So I have y equals something times 1 plus 9. Okay, there's only one thing it could be, which is 1. So that means that I believe that the formula for this guy could be y equals x plus 9. Let's see if that works. Subbing into a couple other ones. Okay, we have 3 for the x. 3 plus 9 is 12. Beautiful. 4 plus 9 is 13. Beautiful. I found it. All right, now let's try to find the other harder one. So for this guy, we know that we have y equals something x plus something. What's going to work here? Okay, I can see that the first one is 3 higher, the second one is 7 higher, third one is going to be 11 higher, the next one is going to be 15 higher. Okay, let's explore this a little bit. We don't have a 0 situation, so we can't go with that. However, we do have a situation where whenever we multiply our first unknown times 1 plus something, we get 4. So what times 1 plus something equals 4? So we can keep it going with that. I'm going to try to experiment with just saying, oh, let's try 4 in here just to see, because 1 times 1, no, we'll do 3. 1 times 1 plus 3 is 4. 1 times 1 plus 3 equals 4. So let's try it on another one. Okay. How about the 3 for x? So 1 times 3, so I'm going to be substituting now. This is just like the homework that we had from Tuesday. Let's see if that works. I'm going to leave those circled in. So we have 3 plus 3 does not equal 10. Okay, so it's not going to be that. What if we did 2? 2 times 3 plus 10. 2 times 3 plus 3, which is 6, 7, 8, 9. Nope, that does not work. So that's not going to work for us. Okay? So I'm back to the drawing board. Y equals something x plus something. How about if I switched it around a little bit? What if I had a 2 situation in here? Because I like the number 2. It's my favorite number. My favorite actual number is 22, because what's better than your favorite thing? 2 of them. I have 2x plus something. So if I had 2x plus something equals 4, now I'm going to substitute in for my 1 and my 4. Let's see if we can make this work. 2 times 1, see if it equals 4. 2 times 1 is 2, plus 2, let's try that out, 2 equals 4. Cool, that works. Let's try the next one out, see if it works. If it works on every single one, that means that this formula will be the way to go. So we have x times 3, 6. Okay, 6 plus 2 is 8. That one doesn't work. That one does not work. Now this is what makes it difficult for the homework that we had last week, or on Tuesday, because sometimes you just have to explore a little bit to see what are we going to find, what can we get, okay? So 2 didn't work. Let's start to just crawl up, because in our stuff we haven't really seen a whole lot of really big numbers. So let's see if we can just crawl it up a little bit higher. So we just tried 2. Let's try 3. Y equals 3x plus something. So let's try it. Let's try with the first one. We're going to substitute in, erasing out there. I'm taking my time with this. If you guys already have this one, you guys can go ahead and skip through and see when I pop up. So I'm substituting in. Let's see if we got 4 and 1. 3 times 1 plus 1 equals 4, okay? So let's see if that would work for the other one. So we have 3 times 3, and then so there's the 3 that we just used, so that put 10 over here. 3 times 3 is 9 plus 1 is 10. I think we might have found what our value is, our coefficient is. Let's try it on one other one. Okay. So let's try the 5 and 16. 3 times 5 plus 1 is 16. Boom. We have found it. Could go all the way through, but I trust that we've got it. So now we've just found that y equals 3x plus 1. Ding, 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 ding. Okay, 3 plus 1, not proportionate, good. X plus 9, not proportionate, good. Y equals 3x, it is proportionate, constant property is 3. Okay. That has the answer right there. Did I click it twice? Interesting. Allie can run 3 miles in 1 hour. How many miles can she run in 2, 4, and 6 hours? This is a situation where if you see a word problem and it's just saying, or it's introducing a multiplication problem, that means it's going to have a consistent proportion. Okay, the cop is going to be on there. So we have a equation. Oops, don't go. We have an equation of y equals 3x because it's just multiplying whatever our x is times 3 to get how many miles that they ran in 1 hour. Okay. Tell if the table is proportional. Give the constant proportionality. Yes, it is proportional, and the cop is 30 because that's the number that's right here. This would be our k from earlier in. It's an ugly k. That would be our k from earlier in the notes. So you know what? I'm going to stop this video. I think I'm going to do an example from the homework. Maybe. We'll see. Yeah. We'll see. I'm going to stop this and I'm going to look at the homework to verify that you guys don't need more. Goodbye. Enjoy a 3-day break.